Hi everyone. So in this video, we're going to work through a year 12 question on mechanics from the AS sample paper. Now, this question is about SUVAT equations. So we have here a car moving along a straight horizontal road with constant acceleration. Now, with any mechanics question where you see constant acceleration, the SUVAT equations apply. I mean, you may not need to use the SUVAT equations, but if you do have constant acceleration, you can use the SUVAT equations. So there are 3 points A, B, C in that order on the road, and the distance A to B is 22 meters, and the distance B to C is 104 meters. The car takes 2 seconds to travel from A to B, and 4 seconds to travel from B to C. Part I, find the acceleration of the car. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018, and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams, and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app, and you'll be able to access all of these 2027 predictions. Okay, so as we just said, this is going to be using SUVAT. So what we can do is we can use SUVAT for the first stage of the journey. So from A to B, from A to B. So let's write down our SUVAT letters. So S, the displacement, I mean, from A to B, that's 22 meters, as we can see. The initial speed of the journey, we're not told that, so I'll just leave that blank for now. Then we have the final speed, which we don't know as well. The acceleration is what this question is all about. I'm just going to call that A for this question. So A equal to A, acceleration. And then the time for this first stage of the journey is 2 seconds. Now, we're going to utilize, or we're going to want to utilize, one of the SUVAT equations. It makes the most sense in this case to use an equation involving V, because V is the final speed for this stage of the journey, yet the final speed for this stage of the journey is going to be the initial speed for the second stage of the journey from B to C. Hopefully that makes sense. So it makes logical sense that we use an equation with V and we ignore an equation with U. So if we go to the formula book, we look at the SUVAT equations. Which equation does not have a U in it? It's this one. It's S equal to VT minus half a t squared. We're going to use that one. So we've got here a displacement 22 is equal to VT. So V times 2, that's going to be 2V. And then minus a half times the acceleration, and then the time squared. So 2 squared is 4. So half of 4 times A. So half of 4 times acceleration. We'll just simplify this. So 22 is equal to 2V and then minus 2A. Now what we can do is we can rearrange this equation for V, and then we've got some result for V. So we can just add the 2A to the other side. 22 plus 2A equals 2V. We can divide by 2. So therefore, the final speed from A to B is 11 plus A. Perfect. So we've got that final speed. Now we're going to use SUVAT again. Use SUVAT from B to C. So for the second part of the journey now. So again, we'll write down our SUVAT letters. So we know that the displacement for the second part is 104 meters. So 104. The initial speed is what we just found, because the initial speed at B was the same as the final speed from A to B. So that's going to be equal to 11 plus A. Now, the final speed for this part of the journey, we're not told that, so we don't know that. We'll leave that blank. The acceleration is still A, because it's a constant acceleration. And the time for this part of the journey, we're told, is 4 seconds. So that's 4. So now we've got to utilize a SUVAT equation with S, U, A, and T, but missing V. We don't want to include V. So we're going to use the SUVAT equation, or we're going to use the equation S equals UT plus half AT squared with this one instead. So the S is 104 is equal to U times T. So in this case, it's going to be 11 plus A multiplied by 4, and then plus a half of the acceleration, and then the time squared, 4 squared, is 16. So then that leaves us with 104 is equal to, expanding the brackets, 44 plus 4A, and then we've got half of 16, which is 8, so 8A. So we have 104. We can minus the 44 onto the left side, actually, so this gives us 60 is equal to 4A plus 8A. That will be a 12A. So 60 divided by 12 will give us an acceleration of 5 meters per second squared. And that's our answer for part I. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now then, let's move on to part II. So find the speed of the car at the instant it passes A. So in other words, we're trying to find the initial speed of the car. So what we're going to do is we're going to use SUVAT. So we're going to use SUVAT from A to B because we're trying to find the initial speed. We're trying to find the speed at A. That's the initial position. So let's use SUVAT from A to B. That makes logical sense, okay? So again, the displacement from A to B, that was 22, I think it was. Yeah, 22. The initial speed, that's really what we're trying to find in this question. The final speed, I mean, we knew from our calculation before what the final speed was. We knew that that was 11 plus A. So now we know the acceleration is 5. So 11 plus 5, that's 16. So we can say that's 16. We know the acceleration now, that's 5. And the time for the journey, I mean, we knew that that was 2, wasn't it? It was 2, yep, 2 seconds for this part of the journey. So basically, we can just pick our favorite SUVAT equation here. I'm going to use probably the easiest one. So use V equals U plus AT. So what I will just do, because we're looking for U, I'm just going to take away the AT to the left side. So V minus AT equals U. So therefore, that means that U is equal to V, which is 16, and then minus 5 times 2. So 16 take away 10 is 6. So the initial speed is 6 meters per second. Now, hopefully that all does make sense. If you do have any questions, feel free to drop a comment below and I will try to help you out.